Introduction to IV Therapy. In this video, I'm going to provide you with a little bit of background information on IVs. This will just give you a good idea of what's going on with different problems involving IVs with different drug calculations, just so you have some information about the tubing, about the setup, and so that you understand where the values are coming from for these flow rates. So first we're going to start with the types of IVs. So we're going to look at a primary IV and a secondary IV. The primary IV is used for continuous fluids and electrolytes. The secondary IV is the IV that's used for medications. So it's connected to the primary IV, and sometimes you'll see the secondary IV meds abbreviated as IVPB, which is IV piggyback, or IVR, which is IV rider. When working with IVs, there are different types of tubing. So there are two different categories or two different types. The first one is microdrip or pediadrip tubing. This tubing is used for children, and there is a certain drop factor for microdrip tubing or pediadrip tubing, and that is 60 drops per 1 ml. So when we look at our tubing, the size of the tubing determines our drop factor. So if I'm looking at this microdrop tubing, 60 drops are contained in 1 milliliter of volume. So if I look at the right-hand side here, I know this is a little bit blurry, but it says microdrip chamber. So if we look at those drops in that chamber, those drops are pretty small. The other type of tubing that we have is macrodrip tubing, and that would be labeled on the package as to what specific drop factor the macrodrip tubing would be. So 3 common drop factors would be 10, 15, or 20 drops per milliliter. And here, if we look at our macrodrop chamber, you're going to see that the drops are a lot larger than the microdrip tubing. So that tubing is going to have a larger diameter than our microdrop tubing. So when we're looking at our IVs, we need to know the size of tubing, because that's what gives us what's called the drop factor. And that drop factor is going to be part of our calculation for our flow rate. Let's take a look at IV setups. So there is an IV bag, or it could be an IV bottle. And you'll see that at the top here. So here would be our bag, or in this case would be our bottle. The one on the far right here would be a plastic bag. So the contents and the volume will be printed on the label. So that's something that's very important to check, what exactly we're working with. And the volume, how many milliliters, would also be very important. From that bag, or from that bottle, you'll see the drip chamber. So our drip chamber is located here. Or if we look at the far right, we'll see that drip chamber right here. So when looking at our setup, we would use the drip chamber to set our IV. If I'm manually setting the IV, I would count drops in 10 or 15-second intervals by counting the drops in the drip chamber. I would adjust those drops using what's called the roller clamp or the slide clamp. So in each of those setups, I can see that clamp, and that compresses the tubing to control our flow rate. Next, we have our injection port, and this is used for our secondary line or our injection of medication. And then we have the hub connector, which connects to the IV catheter. So it's just important that you can see the different setups of the IV so that you have an idea of what we're talking about when we talk about the drop factor, the drip chamber, and how to set an IV. There are different solutions that are used with IV, and the most common one is probably normal saline. So our abbreviation for normal saline is NS, and normal saline is 0.9% sodium chloride. So 0.9% means that we're looking at less than 1% sodium chloride, or less than 1% salt in that solution. So normal saline is just water and salt mixed together, which makes that saltwater solution or normal saline. And again, that concentration is 0.9%. Our second solution we're going to take a look at here is 1/2 normal saline. So 1/2 normal saline would be half of that strength, so it would be 0.45% sodium chloride. So again, this would be a really small amount because it's now less than 0.5%, but it's half of our 0.9%. Our next solution is D5W, and that stands for 5% dextrose in water. Dextrose is a sugar, so this is like a sugar solution or an electrolyte solution. Our dextrose solutions could be different strengths. So you might see something like D10W, which would just be 10% dextrose in water, or D20W, which would be 20% dextrose in water. Okay, so D5W is just one example, but when you see the D and the W, you're looking at that dextrose solution, and the percentage is what is in between those two. Our next one is LR or RL, and that stands for lactated Ringer's solution or Ringer's lactate solution. Okay, so you'll see it both ways, either LR or RL, and that solution would be an electrolyte solution. And the last one you'll see in some of the drug orders is KCl, and that stands for potassium chloride. So these abbreviations are important just so that when you see an order, you know what these abbreviations stand for. So from here, when we look at our IVs, we're going to talk about our flow rates. So we have a gravity flow IV and we have an infusion pump, and we'll look at the different rates for each of those.